Hello, everyone, and welcome to Africa Fire Mission's weekly virtual training session. My name is Mike. I'm a project coordinator here with Africa Fire Mission. Super excited that you all took time out of your busy schedules to come here and join us for training today. Today, we're joined by Mark Fyest. Mark's been doing a few trainings for us here online. He's going to be joining us in person here in November. We're super excited to have him here today. He's going to be talking, again, we're going to talk about HazMat, and we're looking at the sort of operations level today. If you stick around for at least 70% of today's training, which is usually 40 or 45 minutes, you'll receive a certificate of attendance for today's training. Keep your eye in the chat. I'll be posting a link to our Google Drive where you can attend other classes that we've taught so far this year. You can watch the video. And if you answer a few questions about those classes, we'll get you a certificate of attendance for those as well. Before we get started with our class today, I'm going to pass it over to Jose, who's Africa Fire Mission's fire safety advocate, for a few words of encouragement.
Thank you so much, Chief Mike. I truly appreciate you. Thanks, Mark, for coming through. I'm looking forward to seeing you in November. And guys from Zambia. Zambia is the new kid on the block, and I'm so excited. Everybody's usually so excited to join in. Guys from South Africa, Mozambique, Botswana, Ghana. Oh my gosh, the list is endless. So today's encouragement really, I was just thinking about that phrase that goes, risk much to save a lot, to save much, or risk a lot to save a lot. My mind is just went back and was like, hey, for you to risk much to save a lot, or risk much to save much, you need to have done something in the background. What does that something mean? It means that you have to undergo some training so that you can be able to know how much risk can you undertake so that you can save a lot. And for me, I just want to encourage you to tell you that do not stop training, And the training also for me is by you going also to doing researches on YouTube and reading a lot about firefighting or fast responding, so that when you are gotten with such you've gotten such a challenge of risking much to save much, you will know when to say stop. So please, guys, don't go risking and you have not trained. We don't want to call you a hero. Heroes are the guys who are already gone before us. So for you, just risk much to save much if you have trained a lot. Thank you so much. That's a word of encouragement. Back to you, Chief Mike.
Thank you, Jose. We appreciate all the work that you do out in the community, everything you do for Africa Fire Mission and the firefighters in Africa. If you stick around after today's class, we encourage you to stick around. Jose hosts a tea time afterwards where you can ask questions about today's class or anything else that may be on your mind. I invite you all to stick around for that if you're available. Without sort of further ado, though, we're going to pass it over to our instructor of the day and let him begin to take things over. So go ahead, Mark. Thanks for being here.
Thank you very much, Mike. And everybody, greetings. Hello, how are you? Good to see you all again. It's been a while since I've been with all of you in this format in terms of teaching. So it's good to be back and to do a bit of teaching with you fine folks today. As you can probably tell by the picture, I'm in uniform, so I'm working right now. I'm on duty. I am the battalion chief on duty today for at where I work in this department. So you may hear the tones going off, hopefully not. If we do get a call, you may hear those tones, but I'm not out of service until I'm done with you guys. So I get a break until about 10 o'clock my time. And then I'm going to go back on duty and do my normal stuff there. But we're going to look at the topic of HazMat, and it's my understanding that you looked at this a little bit last week in terms of an introduction or an awareness approach to HazMat operations. So my thinking today is to kind of build upon that a little bit, not get too in depth. We only got an hour, less than an hour, but kind of build upon it a little bit to help arm ourselves or educate our brain box, our minds here, with a bit more information about how we are going to approach calls of that nature. Because as Jose led in this morning with about not being a hero, that's very applicable to any call that we go on, especially with calls of a hazmat nature, because we cannot see the chemical contaminant. 8 times out of 10, when there is a response that we are responding to that involves a hazmat material, we are not going to know right away what's in the air or what's been spilled out as far as the contaminant, the product, until we start doing some fact finding, some observation, and start to set up our defense systems to prevent us from being contaminated. When we rush into a scene that has a spilling liquid or a off-gassing of some product or a release of a hazmat product of some type, when we rush into that without the proper information and the proper training, as Jose also mentioned, as well as the proper equipment, that is where we find ourselves on the receiving end of some pretty bad news. And that's going to be either us receiving catastrophic injuries that can debilitate us in a number of ways, or even worse, fatality. It'll be our last time going to a call. So we don't want to be those heroes. We don't want to be the kind of guys and gals that just rush in. We want to make sure we take the time. We do a thorough size up, and the size up involves gathering information. And in the hazmat world, which is nothing new, it's been around for a long time. For the fire service, we have gone on many calls that involve hazmat materials. But in the hazmat world, we need to take the mindset that we have to slow it down. This is where the police are experts in this certain area. Up where I am and where Mike lives and works, the police do an excellent job of slowing things down. When they get on scene for a hostage situation or a kidnapping or any kind of takedowns or anything like that nature, they slow the scene right down. They take their time. They process information, they gather information, make educated decisions, and then they act in due course. And that's what we have to do. We have to slow things right down, and we have to process what we're seeing, what we know, and what we need to know before we begin to act in any kind of fashion thereabouts. So let's start to look at this in a little bit. I'm going to share my screen with you right now, and I'm going to bring up one PowerPoint that we'll look at. I have two, but one we'll start off with. And we're not going to do it all. We're going to just look only at a few things that we have here. And let me get into my presentation. Oh, there we go. So now you see my title page. So as I mentioned, when we arrive on scene, we don't want to get that contaminant into our body. That is the worst thing we want to have happen, either in our body or on our body. That's going to be the worst day of our lives, because depending upon what that contaminant is and how lethal it is, will have dire consequences. The name itself, hazardous materials, is what's the big red flag that's telling you and telling me, hey, don't come near me, because if you come near me, I'm hazardous. And here we see in this particular slide, we have 4 ways in which a contaminant or a hazardous material can enter our body. And so the one way is by inhalation. That's breathing it in. As you're breathing right now, listening to this awesome guy talking, you're breathing normally, naturally, And just as you take in a breath of air, so can we also breathe in a contaminant that's in the air that we don't know about. And that's it. It's in our body. The respiratory system, which is our lungs, our trachea, and our mouth, it is the biggest system that's in our body, and it's the most easily compromised. What that means is it is the easiest way for anything to get into our body is by us breathing it in, because we have to breathe. And so we naturally are breathing. And when there's something in the air, a lethal gas, a vapor of some type, and we can't detect it, there's no odor, there's no smell to it, there's no observable shape that we can see, there's no discoloration in the air, it's invisible. We are breathing it in. And we do that, we are compromising our system, and we will feel the effects of that hazard either right away, or we'll feel the effects a little bit later on a much longer term basis. So the first way is by inhalation, which is the easiest way for us to breathe in something. The second way is by ingestion, eating it. All right, we have to eat and actually get that contaminant into our mouth and swallow it. That's what ingestion is referring to. The third one is by absorption. This is where we have something coming in contact with our skin, and it absorbs itself into our body. So just like a sponge that absorbs water off the tabletop surface, our skin can absorb that contaminant into our body through the pores of our skin, and that's how we have absorption. And then fourthly is by injection, and this is where we have something that is penetrating our skin, a sharp object of some sort that has punctured our gear, penetrated the skin of our body, and in so doing enters in or brings with it that contaminant as well. Those are the four methods. Which one is the easiest? I mentioned is inhalation. Which one is not so common will be usually injection, as well as ingestion. But absorption, inhalation are the two most common, and the easiest one being by us breathing. How do we protect ourselves against these four hazards, or these four methods of entry into our body? Well, by the inhalation way, it's very simple. We wear our SCBA, our self-contained breathing apparatus. That's the one thing we have to make sure we're always wearing. It is the best and the highest form of respiratory protection that any human being can put on. So if we're wearing our SCBA, we are right away eliminating the risk and the chance of that contaminant getting into my lungs, of me breathing it in, because now I'm breathing off captured air from my bottle. That's the one way. The other way is to not get too close, to make sure you're far enough away from perhaps the hot zone, which is the actual site where the situation is taking place and unfolding. If we are far enough away that we're not right in the actual plume or the vapor cloud that is being given off, we're also going to be removing the risk or the chance of breathing in those vaporous contaminants. By the ingestion method, how can we prevent that from happening with us? Well, we don't eat dirty food. We're not going to eat contaminated food. So if we're on scene of a HazMat call, we're not going to be ordering our lunch and bringing it down to the site and eating the lunch right there in the hot zone with the HazMat materials also in the same area. Or we're not going to have our hands unwashed and then go grab food and start eating our lunch in the cold zone. It's the same idea in terms of ingestion. If my hands are dirty and I touch my sandwich or my lunch and I eat my lunch with my dirty hands, that is also ingestion. The absorption, how do I protect myself from that? Well, I'm protected if I wear my gear. If I wear my firefighting gear, I'm going to remove the possibility of absorbing that contaminant onto my skin. Now, just a cautionary note, the firefighting gear that we wear for structural firefighting, which is awesome for heat resistance and also good for puncture resistance and for preventing cuts and scrapes, is not the best for hazmat protections. Very, very limited in what it can do, but it will help to prevent us from absorbing that contaminant into our body. And then with injection, we want to be careful of what we touch. If it's sharp objects, we don't want to be touching our bare hand on it or our gloved hand and having the possibility of something like that puncturing into our body and then entering that hazmat material into our system in that way. So I mentioned about slowing things right down. We want to slow things down and gather information. And one way we can do that is by using our eyes. You can observe and see what we're looking at. And that's why you see here the title slide here, identification. Identifying is where we are observing, we are looking with our eyes, we're picking up clues that we can use to our advantage to help make a good decision. And with the world of hazmat, we can identify container shapes and container sizes. When you look at the different ways in which we transport hazmat materials in different parts of our world, in one sense, we have the same containers used all around the world. In other sense, in other aspects, it might be more localized. But it's good to know what those containers are in your area. And if you can see these containers in your area, it's going to help you to make that identification and to hopefully try and identify what that material might be that you're dealing with. Right. So for example, in our picture we're seeing right now, we see two large containers that are used for storage. They're static, they don't move, so they're not mobile. They're staying right where they are, and they are large in volume. The smaller one to the right has a certain type of a dome, half dome roof on the top of it. When we look at something like that, we can assize or assume based on what that kind of container would commonly hold, it's going to be a liquid that's going to be in there. It's a liquid substance that's in that container. As far as volume, it's going to be thousands upon thousands of gallons or liters that will be in there. As far as the type of liquid, it's going to be, for the most part, a flammable liquid, something that can catch on fire and will have a vapor release rate that may come off that. And the roof can kind of lend into telling us what that kind of liquid might be. If it's like a domed roof, it's a floating roof especially if it floats up and down with the liquid, that's a very vaporous substance that gives off lots of vapors and is very easily ignitable. If it's a flat roof that's solid, it's not going to be as vaporous or as ignitable as, say, a floating roof or a domed roof. So just right there, we can tell in that one large, round, above ground, static storage vessel, what kind of material I'm dealing with right from the start. And that's how containers can help us identify what we may be dealing with. That's one way for us to gather information. It's like, there we go. Another way, you can see here, again, the pictures are showing to you, this is showing you mobile vessels that are used to transport dangerous goods or hazmat materials from one location to the other location. And again, based upon what part of the world we are looking at, some of these things, like on the highway, transport trucks may look different in terms of local manufacturers who make those trucks and what's being used, as compared to more so international, which you see more towards the bottom, like on water and also what they call intermodal containers. On the water, a ship is a ship. They don't change in terms of where they go from one place in the world to the next. So large ships carry lots of different containers, be it box type, mostly are box type, but they carry lots of different types of commodities on board. And so when we look at a big, large cargo ship, we know it's going to be packed full of something, and a lot of times it's going to be a lot of hazmat materials that may be on there as well. But right below that ship is a picture, excuse me, of a intermodal container. And that container is an international type of container. So it's designed to be used to ship from where I am right here near Toronto, Ontario. It can be shipped down to Columbus, Ohio, and then shipped across the ocean all the way to South America. And then from there, it can be shipped down to South Africa and other parts of the world, because it's designed to go internationally from place to place to place. And it's also designed to be used by different transportation devices, be it a cargo ship, be it a rail, like on a rail line on a train, or by highway on an actual tractor trailer or a flatbed or some kind of mobile highway device that's used. So it can be used on those three different conveyances. And that's where we may see in any parts of the world that particular container shape and size. And so even that itself can tell us what kind of material I may be dealing with, and we can get an idea of the quantity of how much I'm dealing with, the state of matter. Is it a liquid, solid, or a gas that's inside that container? As well as if it's identified, which we'll look at a little bit later on this morning, hopefully, if it's identified with a placard or something on the outside, it can tell us also what type of material, as far as is it a flammable gas, is it a combustible solid, is an explosive, and so on and so forth. I'm going to skip a couple things here because it doesn't really pertain to us. The one thing that we do want to make sure we're aware of is in the hazmat world, we do transport radiation or radioactive devices or materials. They are transported in large quantities, small quantities, and depending upon what the item being shipped in, it could be an everyday household appliance that may contain some radiation in there. But just for our own benefit, it's good to know different types of radiation that may be out there. And so the first type is called alpha. And alpha radiation is very, very minimal in terms of harmful effects. And we can stop alpha radiation with a simple piece of paper. So it doesn't take much to stop alpha particles. Even our clothing can stop that from coming into our body. So very, very harmless, very, very minimal. Then there's beta, a little more severe in terms of its effects and harmful effects. And that might take maybe a bit more of a metallic object like aluminum to try and stop those particles from making its way through. Then there's gamma. Gamma radiation is very dangerous. It's what we use for conducting x-rays. So when you go to the hospital and get an x-ray done on, say, a broken bone or something, they're using gamma radiation to see your bones. And so that can pass through our skin and our body very easily with no resistance, unless we use something like, say, lead. So a lead-lined vest or lead-lined garment or lead-lined walls. That's what it takes to stop gamma radiation from continuing on through. So we don't carry with us lead-lined vests or lead-lined structural firefighting gear. And so if we came in contact with any kind of gamma radiation, it's going right through us automatically. And then the fourth one is neutron, which is, of course, the extreme worst. Very, very harmful, and that's going to involve concrete to be utilized to stop that. And that you're going to find those more so in your power plants that produce energy. So nuclear power plants, we use a lot of concrete to contain and not allow neutron radiation from carrying on. What I want to focus on here now, next little bit here, is in terms of identification. There's there's a book, a resource that everybody can have access to around the world. It's available. It's free of charge, and it's orange. It's always orange. It's called the Emergency Response Guide, the ERG. And the ERG is updated every 4 years. So you saw the date on here, 2020. So there's a new one coming out in 2024. And this book is a valuable asset that every firefighter should have with them, whether it's on themselves or on the truck itself, fire truck that's responding to the actual call. So every fire truck should have an orange book in there somehow. Now, this orange book is hardcover, but also it's available on your smartphones or your phones. You can also download an app, the exact same thing, an ERG 2020 app on your phone, and the information in that hard paper-bound book is also in the app. So it's very easy to navigate, very easy to access, information that we may need to know based upon what we see. And I mentioned the orange book because what you're looking at right now on the screen in my little PowerPoint slide here is it's listing off 9 classes of hazmat materials that we can easily identify, or we can group those materials into as what type of material is it. There's 9 of them. And it's a UN system, meaning it is international. So if the shipper, the person shipping the material, is following the UN system and following local laws and so on, they'll be classifying and they'll be labeling that material in one of these 9 classifications. So class 1, real quick, is explosives, anything explosive. And an example of that might be dynamite. So if I'm transporting dynamite, I have to label it as a class 1 hazmat material. A class 2 is gases. That can be like breathing air, or it can also be flammable gases, right? So anything gas as far as a vapor, that's a class 2. Class 3 is a flammable liquid. Class 4 can be flammable solids. Class 5 is oxidizing or oxidizers. So oxygen is a class 5 substance. Class 6 is toxic and infectious substances. So that's stuff that's going to be harmful to the body, like acid, bases, whatever we can, we don't want to have coming in contact with us as far as causing infection or causing, I want to say it there, like bacteria is also part of that. Biological hazards are also in that same category as well. Class 7 radioactive materials. And then class 8s are your corrosives. That's going to be your acid and your bases that you may come in contact with. And then class 9 is your general category, where if whatever I have as far as a product, a substance, a material, and it doesn't fit in the first 1 to 8 categories, well, we throw it in class 9, miscellaneous. Just put it in there. We also put it in that class 9 if it's also below a certain weight and quantity. So there's rules surrounding how we label these products, and it's also based on how much in terms of weight and quantity. So if I'm below that threshold of what's needed, it can be put in class 9. If it's over that threshold or that limit of weight and quantity, then it has to be identified as either class 1, 2, 3, 4, 5, 6, 7, 8, and labeled as such. So those 9 classes that we have there are also, as I'm going to show you right now, they are listed for us in the ERG. So if what you see here today, you forget it, tomorrow or the next day, if you got a copy of this book or the app on your phone, it's listed for us right there on the white pages of what those 9 classes are. In conjunction with those 9 classes, each one has a corresponding placard that we use to label the container that the product is being shipped in or being stored in. And these identifiers, these labels, these placards are unique to each class of 1 through 9. They are unique in terms of its color. So each class has a assigned color that we can easily from a distance identify what that hazard class might be. So it's not a matter of having to get up right close to see what it is. I can be quite a ways back, and using my eyes, I can see, in this case, a red placard on that container or on that particular truck or on that particular device used to hold that product. And I know that because it's red, that's going to be a class 3, that's going to be a flammable liquid. That's what's assigned to that particular class of hazard. It also is going to have a picture. You can see there in that red placard on the word flammable, right above it, there's a picture. There's a picture of a fire. And again, from a distance, I can use that to tell me what that substance is. It's easily going to catch on fire or will catch on fire. So if I can't speak English and I can't read that word flammable, or I can't read period, I can at least see the picture and I can know that it's going to catch on fire. That's not a good thing. The other unique thing is a numerical ID number. You can see in the middle slide here, this one right here, it has a 4-digit number assigned, 1090. And that unique number is what's used to identify that particular product. And that number is used with the ERG. So I can actually look up in my ERG what that number is. I can look up 1090, and it tells me that that product is acetone, highly flammable, a flammable liquid. Now I know the product name. I know it's flammable. I know it's a liquid. And so now I can start using that information to my advantage by maybe pulling ourselves back a bit, setting up a perimeter, preventing the public from getting access and up close. I may start to do things like pulling off a hose line or two and get that hose line charged, maybe setting up a foam system to apply foam should I need to apply it. If there is any kind of spark or ignition source that will ignite that particular liquid, at least I got my hand lines out ready to go, and I can right away start to suppress that fire. It can also tell me how I'm going to prevent that liquid from spilling out further and getting into harm's way with everybody else around. So it's going to lend into what can I do to defensively stop it from leaking, like maybe digging a trench or laying down some absorbent booms around the liquid spill as a way to contain it and prevent it from becoming a worse hazard or making the situation worse for everybody involved. So identifying is a key aspect, and this is where we use to our advantage labels and placards that are going to be sometimes and hopefully all the time affixed to the outside of the container you're actually encountering. Again, in our orange book, okay, our orange book here, I'm going to get to the page for you. Probably can't see too well, but I'll hold it somewhat close. Our orange book has a listing showing all the 9 classes and what each corresponding color is for each class, and what the pictures in the diamond placard may look like, as well as wording, so that if you came across and saw that particular color, you could easily open up this book to this page, and you can easily identify what type of hazard class that is. And then also there's you can't quite see it too well, but might get a little closer. You can see there's a black number at the with each one of those diamond placards. And that black number works in conjunction with these orange pages that are in the back, in the middle of the book. And these guide number, the orange pages, is where we find all the information that tells us how we are to approach it, how we are to deal with it, what we must be wearing for PPE, protection for ourselves, how do we fight it if it catches on fire, how far back our distance should be for our initial isolation, as well as evacuation of the entire area should we have to evacuate. It also tells us what the potential health hazards are. So we're fully aware of what that particular material is going to do to us should we come in contact with it. It's also going to tell us what the first aid measures are going to be as well. So if we have to apply first aid medical treatment to somebody who has come in contact with this material, it's going to tell us what to do. So it's a very, very useful resource that will help us to make educated decisions when we are approaching a situation of, let's say, a fuel tanker truck that's carrying petrol from the refinery to the petrol station, and then it collides with a passenger vehicle, and then as a result of the collision, we have a large fire or explosion occur. That's a hazmat situation right there. And so we can use this book to help us decide what we're going to do, how we're going to do it, how far back we need to be evacuating, how far out we should be isolating and preventing the public from getting in closer to protect them from not also being caught in the situation as well. Right. Okay, so all I've mentioned is what is there, again, showing as far as how these are very unique in the color, the symbol, the number. At the very bottom, it also has the actual hazard class number, class 3. So you can tell right away it's a class 3 product that I'm dealing with in this situation here. Okay, so what are my colors? So the colors are: orange is always referring to an explosive device. If it's an explosive nature like dynamite, that's a very easy example to give, or nitroglycerin, that's another good one. It's going to be orange. So orange always refers to explosive. Yellow is going to be referring to your oxidizers. So whatever is an oxidizer is going to be a yellow, and that's always synonymous with that one. Red is always flammable liquids, or anything that's going to be catching on fire is always red. White is going to be a health hazard. So if it's a white placard, it means it's not good for your health, like a toxic substance, a poison, something corrosive. That's always going to be a white background. If it's got a blue background, it's going to refer to it being as water reactive. So the product itself does not do well when it comes in contact with water. A good example, that's magnesium. So a lot of vehicles these days have magnesium parts, like the brakes, the rims for the tires, the steering columns, what else? Other parts, dry shafts. Lots of parts are magnesium nowadays. And when that comes in contact, when it catches on fire and water is applied to that, it will not react well. It actually reacts in a very violent way. So anything blue refers to it not being water reactive. And then green always refers to something non-flammable. So if I have pure oxygen in a medical cylinder that's being taken to a hospital or being used in a hospital, it'll be labeled with a green background. That means it's a gas, it's a vapor, but it's not flammable, right? So breathing air, I'm breathing right now. If I put that into an SCBA cylinder, that'll be labeled as green as well. But an oxidizer can also be pure oxygen, because if it does leak out, it will contribute to oxidation, or it will contribute to that environment becoming very either explosive, or it can be very flammable as well. So those are your 6 common colors that we use quite a bit when we're identifying like a placards in the background to show us, as you see here, and that's the page taken out from that orange book, what they may look like, right? So let's look at class 1 here in the left corner. Those are all orange, and if you can look at them somewhat closely, you'll see, for example, in the one, it shows a picture of a exploding fragmentation. So telling us by a picture, this is explosive, right? Besides the big word saying explosive. Look there at class 2, right? We can have the yellow, which is oxidizer, like pure oxygen. We have the green, which is also for a non-flammable gas, like regular breathing air. We also have red, which can be flammable, right? So like I said, acetone might be also in that class there as well, but red referring to it being actually, it's going to catch on fire, ignite. Or it could be a white background referring to a health hazard as like saying being a poison. That'd be your class 2 different colors. In your class 3, it's always red because class 3 is flammable liquids. So everything in that class will always be a red background. In the class 4, we can have a combination of red and white. So red and white refers to it's a flammable solid. So it's not a liquid, it's a solid, but it's also very flammable. But you also notice it's got a blue one. And that blue refers to that when it comes in contact with water, it's not going to react well. So it's not water reactive. Class 5, you're going to have majority, it's always yellow, as a oxidizer is going to be labeled as or color coded as. And you may see sometimes a red/yellow, again, identifying as being an oxidizer, but flammable. So it lends into the fire process, or will lend into an oxidized environment very easily. Class 6 is going to be your poisonous class. Again, always a white background referring to health hazard, but the picture that you're seeing in the top of that placard is a skull and crossbones. So that's very, very universal, telling us that, hey, if you come in contact with this product, it's not good for your health. You may end up dead, like the skull and crossbones kind of look. So we see that picture. We want to make sure we are not approaching it, right? Not getting too close. Class 7 radioactive is always going to be that yellow-white background with that very common universal picture of the three clover leaf, which is always used to identify radiation. So when we see that, we know that's a very radioactive substance. Class 8, with our corrosives, our acids, our bases, like battery acid would be in this category. It's always, again, white and black because it's a health hazard. And the picture in that placard is showing us something that's dissolving when coming in contact with that particular liquid or substance. So again, showing us it's corroding, it's eating away like an acid or a base would do. Then that class number 9, which is the miscellaneous class, that can be, as you see there, a white and black with striping, or what's usually very common is a red and white with the word dangerous. So we have no idea what it is, but it's labeled as such. And therefore, we know enough to not get too close to it. Right? So those are how each of the 9 hazard classes, how they're set up, how they're identified by the color of the placards, what the pictures look like in the placards, and what the wording associated with it may sometimes be on there as well. When looking at identifying, as I said, we're using our eyes, right? We're looking, we're seeing, we're sizing things up, we're gathering information. What we don't want to do is we don't want to get to a point where we can taste it. We don't want to ever taste it. We don't want to smell it, because smelling it means we're breathing it in, and we don't want to touch it. And if we do find ourselves in a position where I can taste that substance, that's not good. That means we are now exposed to that contaminant. Or if I can smell something, because sometimes products that are being shipped, they may add a scent, or they may add something in so it can be detected by smell as a warning to get away. So if I can smell something, that's not good either. Most importantly, if I'm touching the product, that means now I'm coming in direct contact with that contaminant, and now I'm going to be, or I have been exposed, and I am now having that product coming in contact with me through, in this case, by touch, which would lend into absorption, or possibly injection, or ingestion. If I don't wash my hands and clean it, and I start eating my snack, I'm ingesting what I just touched. So be sure and make sure that when you are approaching a vehicle accident, a call to a facility that may be of a commercial, industrial, a warehouse that has a product that's leaking, or they have a breach of a container and something is now leaking or coming out of that container, and that can be static, where it's like on-site storage, or it can be mobile, like on a truck at a vehicle accident. When you are responding to those types of calls, be very, very cautious and be very, very sure you take your time to identify what it is you're dealing with before you rush in and try and do something. Because when you do, as I mentioned in the very beginning, if you do, and when you do that, you will find yourself on the receiving end of that material's deadly consequences, which we don't want to have. And when we do find ourselves in that position, we are entering into a world of hurt, where it's going to be either long-term or short-term consequences as far as the effects of the health that we're going to experience. So be sure you always identify, use your eyes, look. And a good rule of thumb, I'm going to show you my thumb right now. Right, the good rule of thumb, it's a saying we always use, but in the hazmat world, I'm going to use my thumb to actually protect me. And how do I do that? Well, when I arrive on scene at something, I'm going to take my thumb and then I'm going to close my one eye. And as I back away from that situation, when my thumb covers the whole area, or the whole object, the whole container, then I'm far enough away that I'm not going to be exposed or have the possibility of breathing in or ingesting it or absorbing it, or by even worst case, or by other means, by injecting it into my body. I'm far enough back that I'm protecting myself and the other firefighters. And I'm also hopefully protecting the public by keeping them just as far away as what we are as well. Okay, so I think for today, we're about almost 5 to the hour. I don't want to go too much further because I think if I do, I'm gonna really start to confuse some people, I think, with what we looked at so far, because we can go a lot more into this, a lot more deeper, but it takes a lot more time. And it would take, unfortunately, myself to maybe be there in person to take you through the book and have you use it and to see how it's very beneficial, and to show you examples of different placards and stuff like that, or go for a walking tour and actually walk around where you where your station is to see what can we easily identify right now that we know is holding a hazmat material, right? So hopefully the key takeaways for today that I want to make sure you leave today with in your mind, in your brain box, is when I arrive on scene, I want to identify. I want to identify by container shape, container size, which will dictate if it's a liquid, solid, or a gas. And if I can see a label that might be on that container, and I have access to either a hard copy or on my phone, the ERG, I can use that to start looking up information to figure out what I'm dealing with, how far back I should be, protecting the public. And also, more importantly, making sure you don't, by any means, inhale it, ingest it, get it injected, or absorb it into your body. All right. So thank you for your time. I hope you guys have learned something. If you have some questions, by all means, please ask away if you're able to. And I can do my best to answer them in my limited time here still. And then I'll turn it back over to the host and Jose.
All righty. Thank you, Mark, for today's lesson. Very timely, very valuable. We're going to end the formal portion of today's training. Invite everybody to stick around for their questions here in just a minute. Thank you, Mark, for taking your time out of your schedule to come and join us, and to everyone else. And we invite you all to join us again at the same time next week.